Hello students, Stride here again. Today we look at 11.1 practice problems on defining stoichiometry. Question 1, we have Turpin balanced equation in terms of particles, moles, and mass. Show law's conservation of mass is obeyed. First equation, already balanced, we have 2H2O2 yielding O2 plus 2H2O, or hydrogen peroxide decomposing to form oxygen gas and liquid water. So, all these substances are molecular. Remember, if they are no metals, typically they are going to be molecular. So these are molecular or covalent compounds. So in terms of representative particles, each time here it's going to be molecules. So we look here at 2 molecules, H2O2 yields 1 molecule of O2 plus 2 molecules of H2O. Here you'd have to remember what type of representative particles we have. Also supposed to identify it in terms of moles. That's always easy. We just have to put the moles in there. 2 mole of H2O2 breaks down to form 1 mole of O2 and 2 moles of H2O. In terms of grams, it's one that requires a little bit of work, so we need to go through and change each of these moles to grams. So the molar mass of H2O2, we have to figure that out, and if you calculate that out, you should get 34.02 grams per mole. O2 is going to be 32.00 grams per mole, and H2O 18.02 grams per mole. Using those and doing a little multiplying, we get 68.04 grams of the hydrogen peroxide. Breaks down to yield 32.00 grams of the oxygen plus 36.04 grams of the H2O. So our first 3 answers are here. It says demonstrate the law of conservation of mass is obeyed, and 68.04 equals 32.00 plus 36.04. I should have put grams on each of those. Demonstrates law of conservation of mass is obeyed. Yeah, as you're doing these, try the problems, then use the video to help you figure out anything you might have missed or unclear about, or just to check them. Next question, same thing. It's time we're another decomposition reaction. This time we have carbonic acid breaking down to form liquid water and carbon dioxide gas. This would be the reaction that generates the bubbles in soda pop. The H2CO4 aqueous, even though this is one that does not have any metals involved, we are going to use formula units because when it's aqueous, it dissociates in water, creating ions. Most of our acids are going to be formula units rather than molecules when we see that aqueous. So in terms of particles, we've got, again, always check and make sure we are balanced. We are balanced. So one formula unit of the carbonic acid breaks down to form one molecule of the water plus one molecule of the carbon dioxide gas. Again, key part here, what you got to do is throw in the correct representative particles. Make sure you understand what the representative particles are. And writing it in terms of moles, this most common thing we do using the moles, 1 mole of H2CO3 breaks down to form 1 mole of H2O and 1 mole of CO2. And again, we want to just take each of those, change them to grams, use multiplying by our molar masses. And the molar masses, you calculate them out, you should get something like 62.03 grams per mole for the carbonic acid. For the water, 18.02 grams per mole. And for the carbon dioxide, we get 44.01 grams per mole. Typically on molar masses, if you round it to 2 decimal places, always a good place to try to round them to 2 decimal places. Each one of these is 1 mole, so it is just going to be 62.03 grams of the H2CO3 decomposes to form 18.02 grams of H2O and 44.01 grams of the CO2. And if the law of conservation of mass is always to be obeyed, we should get 62.03 grams equals 18.02 grams plus 44.01 grams, and it does demonstrate the law of conservation of mass to be obeyed. And part C, where we have 4 HCl plus O2 giving 2 H2O plus Cl2. In terms of representative particles, we got 4 units of the HCl. This is aqueous in nature, so as it would dissociate, this will be 4 formula units of the HCl plus 1 molecule of O2 going to form two molecules of H2O. Spell that right. Molecules of H2O plus two molecules of Cl2. And in terms of moles, 4 moles HCl plus 1 mole of O2 yields 2 moles of H2O plus 1 mole of the Cl2. And we switch them to grams. Molar mass for the HCl is 36.46 grams per mole. Molar mass of the O2, 32.00 grams per mole. Molar mass of the H2O is 18.02 grams per mole. And then the molar mass of the Cl2 is 70.90 grams per mole, resulting in, as we switch them into grams, we get them multiplying by the moles. We have 145.84 grams of HCl plus 32.00 grams of O2 yields 36.04 grams of the H2O plus 141.80 grams of the Cl2. And then to demonstrate the law of conservation of masses, observed products added together have to, or the reactants added together have to equal the products added together. And we get 177.80 approximately on each side. 100. That one was supposed to be a 4. And then I think they balance out exactly. Good. Question number 2, we want to determine all the mole ratios. So here we have 3 substances, so we're going to end up with 3 times 2, or 6 mole ratios. And we have to have a balanced chemical equation. It already is balanced. So I'll just start with 1 mole of N2 over 1 mole of O2. And I'll do 1 mole of N2 over the other substance, 2 moles of NO. And we can flip both of those over to get 2 more mole ratios. 1 mole of O2 over 1 mole of N2, and 2 moles of NO over 1 mole of N2. There's 4 of our 6. Now we go to, I've done everything that has an N2 in it, so now I go to the O2, and I get 1 mole of O2 over, and match that up with the NO, 2 moles of NO. And I flip that one over for my 6th mole ratio. Part B, number 2. Here we have 4 substances. 4 times 1 less 3 gives us 12. So we should end up with 12 mole ratios on this one, following the same pattern. I just like to start with the first one. 4 moles NH3. Put it over 5 moles of O2. 4 moles NH3 over 4 moles NO, and 4 moles NH3 over 6 moles of H2O. There's 3. I flip them over. I get the 6th one, so we have 5 moles O2 over 4 moles of NH3, 4 moles NO over 4 moles NH3, 6 moles H2O over 4 moles NH3. So I've completed everything that has NH3 in it. Now I go to the 5O2 over 4NO. 5O2 over 6H2O. That's things with the O2. Now we flip them over. 4NOs over 5O2s. 6H2O over 5O2s. Now I've got 10. Got 2 more. And I just work my way down. I've got now to the 4NO over 6H2O, and flip that over 6H2O over 4NO. Very systematically, we generated all 12 the mole ratios for that one. And our last one for this little part, we got 4 substances again, so we should end up with 12 mole ratios again. We've got all the same pattern. 4 HCl's over 1 O2. Forgot to write moles in there. Moles and moles. 4 moles of HCl over 2 moles of H2O, and 4 moles of HCl over 2 moles Cl2. Flip them all over. 1 mole of O2 over 4 moles of HCl, 2 moles of H2O over 4 moles of HCl, and 2 moles of Cl2 over 4 moles of HCl. And move to the O2, put it on top. 1 mole of O2 over 2 moles of H2O, and 1 mole of O2 over 2 moles of Cl2. Flip, 2 moles H2O over 1 mole O2, 2 moles Cl2 over 1 mole O2. And now we move to the H2O, 2 moles H2O over 2 moles of Cl2. Flip that over, 2 moles of Cl2 over 2 moles of H2O for our 12th mole ratio. That was 11.1 practice problems. Next time we'll be doing 11.2 practice problems. All for now.